question 4 on your quiz asks you to calculate the KQ for the new reaction provided. And you have 3 different chemical equations, each with their own KQs, provided for you as data. So what you're going to need to do for this question is you're going to need to take your 3 pieces of data and you're going to have to determine if you're going to keep the forward reaction with the same KQ, or are you going to need to multiply it to a certain factor to get your coefficients lined up, or if you need to take the reverse reaction and take your KQ to the negative power. So I'm going to walk you through this step by step. The final answer is posted for you on the answer key. So I'm not going to walk you through plugging this into your calculator, but I'm going to show you how to get the setup done. So here's your brand new equation that you're searching for. You're ultimately wanting to find the KQ for 4NH3 plus 5O2 to produce 4NO and 6H2O. So you're going to go through each equation from the data one by one. I'm going to do those for you each in a different color so it's easier to watch. So for my first equation, I have N2 plus O2 to produce 2NO. I'm going to search for any of the compounds from my brand new equation that I highlighted in yellow. I don't have N2, that's not something I'm concerned with. I am dealing with O2 as a reactant, and I'm dealing with NO as a product. So notice that in my data, O2 is a reactant and NO is a product. In my new equation that I'm searching for, NH3 is a reactant, O2 is a reactant, and NO is a product, H2O is a product. So if they stay in the same direction, I'm sticking to the same forward reaction. If they're flipped, then now I'm going to have to take the reverse. In my new equation, my oxygen and my NO are reactants and products, just as in my data, my oxygen is a reactant and my NO is a product. So I'm still focused on the same forward reaction that I was given in my data. That means my KQ is not going to be taken to the negative power. I do not need the flip of it. But what I do need to handle right now is I need to handle my coefficients. So my O2 has a coefficient of 1, but in my new equation, my O2 has a coefficient of 5. That's a little hard for me to go from 1 to 5. And then for my NO, my coefficient is a 2. In my new equation, my coefficient for NO is 4. If you go ahead and look down at the last equation that you're going to do, there is going to be an O2 present there as well. So what I'm going to do is I'm going to ignore this O2 in the reactant for now, and I'm just going to focus on my NO. So my NO, to go from 2 to 4, I need to take that to the second power, and now my coefficients will be balanced. That's all I need to do for this first one. For the next reaction, notice that I have N2 as a reactant. Again, I'm not interested in N2. I have H2 as a reactant. I'm not interested in H2. And I have NH3 as a product. I do need NH3, but I need it to be a reactant. So what that means is, in my data, NH3 is a product. In my new equation that I'm looking for, NH3 is a reactant. So I need the reverse of this reaction. That means I'm going to take the flip. So I'm going to take this reaction and I'm going to flip it over to the other direction. Mathematically, I need to take it to the negative power. Now I need to look at my coefficients. I'm just focused on 2NH3. How does that become 4NH3? I need to take that to the second power. So ultimately my KQ is going to be 1.5 times 10 to the negative 19th, and I need that to the second power for it to show the reverse reaction. For my last equation, now I'm focused on, again, searching for any of the reactions, any of the compounds left over. There's no H2 anywhere in this equation, so that's not my concern. But I do need an O2 and I do need an H2O. Notice that in my data, O2 is a reactant and H2O is a product. In my new equation, O2 is a reactant and H2O is a product. So that means I'm still focused on the forward reaction, which means that I don't need the reciprocal. I'm just going to now look at my coefficients. My O2 over here in my data is a 1. In my new equation, it's a 5. Again, mathematically, it's going to be a challenge to go from 1 to 5. but my H2O is a 2 in my data and a 6 in my new equation. So to go from 2 to 6, that means that I need a 3. And remember, I'm just taking it to the third power because I'm not doing anything with changing it to the flip. If you just did that part right there and you didn't let the O2 stress you out, then now you're totally done with your question. And you take each individual KQ to whatever power they need, and then you multiply them all out to get your final answer. And remember, your final answer is going to need to be in 2 sig figs, and there's no units. The final answer is given to you on the answer key. So this part right here was all that needed to be done. If you now want to map all this out and rewrite it out step by step and double check your work, I'm going to now walk you through that process. So this is now the next part that you could do to show how all of these cancel and which one you're remaining. And we're going to be left with the same exact thing that we have in the new reaction that we're looking for. So my original equation was N2 plus O2 to give 2NO. I just continued the forward reaction, but I needed it to go to the second power. So I'm going to rewrite that equation, but I'm going to change my coefficients so that it reflects that I took it to the second power. So 1 times 2 is 2, 1 times 2 is 2, 2 times 2 is 4. So I'm just going back and I'm looking at my coefficients and I'm taking them to the second power and I'm rewriting my equation. Notice that I have my forward equation. That's the one that I'm focused on. That's why I didn't need to flip it. So now when I move on to the next equation, remember I needed to flip this one. That's why I took it to the negative second power. So I'm not going to rewrite it as N2 plus H2 to give NH3. I'm going to take the equation and start with NH3. And then go ahead and move on to H2 plus N2. And remember that this is still showing as equilibrium. That's not going to make a difference there. It's just about making sure that you actually flip the reaction or kept it the same way as the original data. Now I need to deal with my coefficients. Remember, I ultimately took it to the second power. The negative is already taken care of because I flipped my equation. So now I just take a look. The NH3 originally was a 2. 2 to the second power, this is going to become a 4. The H2 was a 3. 3 times 2, that's now a 6. The N2 was a 1. 1 times 2, that's now a 2. Now I'm going to move on to my last equation. Remember, I still wanted the forward of it. I didn't take it to the negative, so it's just to the third power. So I'm going to rewrite it out again as H2 plus O2, and that's just going to give me H2O. And now I'm going to take care of my coefficients. 2 times 3 is 6. 1 times 3 is 3, and 2 times 3 is 6. And this is now where all the canceling is going to take place. So you can see who you have, who you don't have. So anyone that's not a major player has to get canceled out. How do you know you're not a major player? You're in both the reactant and the product. So immediately I notice that I have N2 as a reactant and N2 as a product. Those two get canceled out. Whoever is remaining is now my major players. So now I just combine them and rewrite it out as my brand new equation. So to begin with, I notice that I have 4 NH3, and that's where that comes from. My next part that I need to include, sorry guys, I forgot one. I have 6H2 as a product and 6H2 as a reactant. That gets canceled. So I not only canceled my N2 because it was a product and a reactant. Remember, I also have H2 as a product and H2 as a reactant. And notice that they have the same number of coefficients, so I'm not left over with any remaining. So now I can go back and see that I just have 4 NH3 remaining as a reactant. The other reactants that I have remaining is my 2O2 and 3O2. So 2 plus 3 is 5O2. And now I've taken care of my 2 reactants. The only remaining products that I have is my NO and my H2O. So now my products are 4NO plus 6H2O. So this part down here, this is just double checking your work. This is proving to you that what you did over here was mathematically correct. So to solve it in one step, you just needed to do this. To double check your work, now is where you could have mapped all this out. You still get the same exact final answer, which you will find on the answer key.